Hadoop technology stack. In this nugget, we're going to look at many of the projects inside of the Hadoop ecosystem. And it can be overwhelming at first when you get into Hadoop and you start hearing about projects like Pig and Hive and HBase and HCatalog and Scoop and Zookeeper and Ambari. And it just keeps going. There's no end to it. So the goal of this nugget is to make sense of all these Hadoop projects, but more importantly, understand which ones are kind of generic and a part of many Hadoop implementations and which ones are built to solve a specific problem, and then also which ones are Incubator, or which ones are projects that are up and coming and things to look forward to here in the future. So we'll kick this nugget off with a recap of the Hadoop core libraries, and I'm talking about Hdfs and MapReduce, and we'll even touch a little bit on the future of Hadoop, Hadoop 2.0 and Yarn. From there, we'll try to break down these projects into categories. I threw a visualization together that kind of groups these projects by data access, data storage, data intelligence, data integration, management, monitoring, orchestration, all that stuff. So we'll try to break out the projects, bring some order to them, and then just get a brief overview of where they all fit inside of the Hadoop technology stack. Along the way, we'll get familiar with some Hadoop Incubator projects. These are projects that were submitted to Apache, and once they get to a stable point and they become highly adopted, then Apache may take it under its wing with full support and turn it into a top-level project. So I'll take you over to the Incubator website so you can see what's currently cooking in the oven, and it's also just a great way to stay on top of the bleeding edge of Hadoop's technology stack. The last thing we're going to do is just look at what a very basic Hadoop implementation might look like. Now, one of my favorite things to do, whether I'm learning a bunch of technologies or I've been tasked with a project that contains many technologies, is to get it all out on paper. Get it all out on paper, play connect the dots to see how they all work together to solve our problem. And visuals are always good anyway, good for learning and good for getting people on the same page. Here it is, the Hadoop technology stack, and this is nowhere near a complete list. Really, I just added the popular ones, handpicked a few Incubator projects, and then obviously we have the core stuff in here. And I know, the first time you look at this, especially if you're new to Hadoop, you go, what did I just get myself into? But fear not, we're going to go through these one by one. In fact, let's start in the middle here. The middle is our Hadoop core, otherwise known as Hadoop Common. And this is going to consist of Hdfs, the Hadoop Distributed File System, something we looked at in the first nugget in the series, and something in the future that we have multiple nuggets on. So we'll get very familiar with Hdfs, and the same with MapReduce, our distributed processing, our programmable interface to access the data stored in our cluster. We've also got many nuggets on MapReduce. So we're not going to spend a lot of time here on those because it's the core of Hadoop. Anytime you talk about Hadoop in any of its tools, they all just sit on top of this stuff. I also want to give honorable mention to Yarn, which stands for Yet Another Resource Negotiator. You gotta love the acronyms and what they stand for. But really what it is MapReduce version 2. So if you see MR2 or Yarn out there, they both mean the exact same thing. This is future tech. This is stuff that's currently in alpha, Hadoop 2.0, and it isn't scheduled to come out until the end of summer 2013. But essentially it's a rewrite of MapReduce 1. Which is what we're going to be learning about, in that it changes the architecture a little bit. In MapReduce 1, you have job tracker and you have task trackers. The job tracker sits on the name node, the task tracker sits on all the data nodes. And the job of the responsibility of the job tracker is to manage resources, scheduling, and it also tracks all of the task trackers. So it has a big job. And Yarn further breaks that down. It breaks the job tracker down into separate daemons. One specifically for managing resources and one for managing jobs. Only they're not really called jobs in Hadoop 2.0. They're called applications, which are a container for jobs. So keep your eyes and ears open for that. That'll be a buzz term of the future, something we'll be learning about a year or so from now once Hadoop 2.0 takes hold and becomes mainstream. Let's move on to some essential Hadoop projects, and let's start with data access. So the reason we need more ways to access the data inside of Hadoop is because not everyone is a low-level Java or C or C++ programmer that can write MapReduce jobs and go get the data. And even if you are, some things in MapReduce are notoriously hard to do. Things like joining, grouping, filtering, all those common things that we do in our SQL languages are quite the challenge to do, even if you are pretty proficient in a programming language such as Java. So we've got some data access libraries to help us out. Pig is one of them. Pig is really just a high-level data flow scripting language. It's really, really easy to get the hang of. And there's not a lot of keywords in it, and you can do quite a bit. But it's all about getting the data, loading it up, transforming the data, filtering the data, and then either returning or storing those results. There are two core components to Pig. There's Pig Latin, which is the programming language, and then there's the Pig runtime, which compiles Pig Latin and converts it into a MapReduce job to submit to the cluster underneath the hood. Hive is another data access project, extremely popular, just like Pig. Hive is a way to project structure onto the data inside of our cluster. So it's a database and a data warehouse built on top of Hadoop. And it contains a query language called HiveQL, right? Kind of like SQL. It's a Hive query language, HiveQL, as we call that. And it is extremely similar to SQL. Not nearly as deep and complex, but all the basic stuff is there. Select, columns, from, table, where for filtering, group by. You have everything that is familiar to a SQL professional inside of HiveQL. So it's extremely attractive for many people that implement Hadoop are obviously going to have data professionals that understand SQL. So Hive is extremely popular because of that. And I should also note that Hive does the same thing that Pig does. It converts these queries into MapReduce jobs that get submitted to the cluster. Moving down the technology stack, data storage. Remember, Hadoop out of the box is a batch processing system. We put the data in Hdfs once and we read from it many times. Well, what if we needed to do seeks? What if we needed to get specific data out? What if we needed to do writes and do real-time transaction processing on top of Hadoop data? Well, that's what we have here in some of these column-oriented databases known as HBase and Cassandra. And these are just Apache projects, but there's a buzz term for you. You ready for this? NoSQL. NoSQL, not only SQL is what that stands for. And that doesn't mean you can't use SQL-like languages to get the data out. What it means is the underlying structure of these databases are not strict like they are in the relational world. They're very loose, very flexible, which makes them very scalable. And that's what we need in the world of big data and Hadoop. In fact, there are a lot of NoSQL database platforms out there. One of the most popular ones being Mongodb. Mongodb is extremely popular, especially amongst programmers, because it's really easy to work with. It's a document-style storage model, which means programmers can take the data models and classes, they're what we call objects in their applications, and literally serialize them right into MongoDB, and with the same ease bring them back into their application. Not to get too far down the NoSQL path here, but that's what HBase and Cassandra are. They're NoSQL-style databases that sit on top of our Hadoop data. There are some differences between them, and it really starts off from where they came from. HBase was based on Google's Big Table, which is a way that we could create a table that contained millions of columns and billions of rows, and we could put indexes on them and do serious data analysis. And HBase is more for data warehousing, data analysis. You can put indexes on them and go to town for some high performance seeks to find the data which you're looking for. And the nice thing about HBase is Pig and Hive natively integrate with HBase. So that's kind of neat that you can run Pig and Hive queries right against the data sitting in your HBase tables. Cassandra has its roots in Amazon's Dynamo data store, and it's really designed for real-time interactive transaction processing on top of our Hadoop cluster. So both of these solve a different problem, but they both require seeking against our Hadoop data. And this is why it helps to, when you're looking at Hadoop and say you've got tasked with a Hadoop project, you're going to be the one that goes through all the different technologies. And while you'll see a lot of overlap, the devil's in the details, as they say, you'll need to look deep, run a few smoke tests with each of them to really find out what is best for your situation. But again, that's the beauty of this open source nature. And why we have so many projects is even though there's going to be some crossover, they were all designed to solve a specific problem in the world of big data. Heading further into the abyss of Hadoop-related technologies, we have just a random collection of projects that span many different categories. Some of these solve a specific business problem. Some of them are a little more generic, like HCatalog. It's known as a metadata table and storage management system. What in the heck does that mean? It means it's a way for us to create shared schemas. It's a way for our tools, Pig, Hive, and Scoop, to interoperate, but also for us to have a consistent view of that data across those tools. Lucene is there for full text searching. So it's an API loaded with algorithms to do things like standard full text searching to wildcard searches, phrase searches, range searches, all that kind of stuff. Hama is there for BSP, bulk synchronous processing. So if you need to work with large amounts of scientific data, it's there to help make sense of it. And Crunch is there for writing and testing and running MapReduce pipelines. We'll talk more about MapReduce pipelines when we get there, but essentially it gives you full control over all 4 phases, which are going to be map, shuffle, reduce, and combine. We just talked about map and reduce, but we'll get into those other phases and how the MapReduce pipeline works. Essentially, Crunch is there to help with join and aggregation of data, because that is, again, very, very hard to do in just low-level MapReduce. So Crunch is there to make it a little easier to work inside of the MapReduce pipeline. So it's a development tool to help us get there. Avro and Thrift, these are data serialization technologies. What is serialization? It's a way that we can take data from an application, package it up into a format that we can then either store on disk or exchange it, send it across the wires, so another application can unpack it and then deserialize it into a format that they understand. So that's all serialization is. It's either data exchange or storage. A lot of the times you'll serialize data as JSON or XML or some kind of binary format. And the difference between these two, Avro is your more generic, we'll call it Hadoop essential framework for data serialization and exchange. Thrift is more specific to creating these flexible schemas that work with Hadoop data, but it's specific because it's meant for cross-language compatibility. So if you built an application that works with Hadoop data in Java, and you want to use those same objects inside of an application that you built in Ruby or Python or C++ or JavaScript or Node.js, whatever, you can consume it. So Avro, generic data serialization and exchange framework. Thrift, language neutral serialization framework. We also have data intelligence in the form of Drill and Mahout. Drill is actually an incubator project that currently, as the name implies, is designed to do interactive analysis on nested data. See that drill down into it to get closer and closer to the details. Mahout is a machine learning library that conquers the 3 C's. What are the 3 C's? The first one's recommendation. Wait a minute. There's no C in that. That's why they call it collective or collaborative filtering. So that's the first C, which is really just recommendation engines. The second one's clustering, which is a way to group related text and documents. And the third one's classification, which is a way to categorize related text and documents. So Amazon uses all this stuff to for the recommendation engines. Music sites use it to recommend songs based on what you listen to, and many other sites use it for not only recommendation stuff, but for predictive analysis in general. Over here on the left, we have our data integration tools. We have Scoop. Scoop's the big one. It's definitely an essential project. It's wildly popular because it makes it easy to integrate Hadoop with relational systems. For instance, say we have the results of our MapReduce. Rather than taking those results and putting them in Hdfs and then needing our to write pig and Hive queries, we can send those results to the relational world so our data professionals can do their own analysis and become part of the process. So Scoop's popular for pushing data out of Hadoop into the relational world, but it's also popular for pushing data from the relational world into Hadoop, like archiving. We no longer want to archive, or I should say need to archive data to tape, when we can push it into Hadoop, where our data will live for infinity and beyond. Right, so that's a great use for it, is for archiving data in Hadoop from the relational world. So Scoop's the big one. Flume and Chuckwa are both real-time log processing tools. So they're frameworks that we can set up where we have applications or even operating systems or services like web servers that generate just mountains of log data. It's a way that we can, in real time, push that information right in Hadoop, so we can also do real-time analysis on top of it. And given some of these other tools, now we have the capability to detect patterns of malicious behavior against things like our web server. So real-time log analysis has a lot of benefits for handling those types of scenarios. Over on the right-hand side, we have tools for managing, monitoring, and orchestrating all the things that go on in our cluster. Zookeeper is a distributed service coordinator. So it's a way that we can keep all of these services that are running across our cluster synchronized. So it handles all the synchronization and the serialization. It also gives us a centralized management point for these services. Oozie is a workflow library that allows us to play connect the dots with a lot of these essential projects. Pig, Hive, and Scoop, for instance. Say that we wanted to run a pig script, and when that was done, kick off a Hive query, and that was done, start a Scoop job. That's what Oozie allows us to do. Workflow. Finally, we have Ambari. Ambari is really cool, holds a lot of promise. Still in incubator status, but I have a feeling that's going to change because it allows us to provision a cluster, which means that we can install services. It's a really easy wizard you walk through. Pick all your services. So we can pick Pig, Hive, HBase, Oozy, Scoop, and install it. It'll go and install it across all the nodes in our cluster. So that's pretty cool stuff. Also, we can manage all the services inside of our cluster from one centralized spot. That means starting, stopping, reconfiguring services, anything you can think of. And then we can also monitor a lot of these projects from Ambari. It has, again, a nice dashboard, nice web UI that we can use. And it currently supports Hdfs, MapReduce, Hive, HBase, HCatalog, Zookeeper, Oozy, Pig, and Scoop. So many of these essentials and even beyond. That's currently what it sits on top of. That's what we can provision, that's what we can manage, and that's what we can monitor. Well, we made it through quite the list of Hadoop projects. And while this isn't a complete list, it's close. There's a lot of stuff in here. And the important thing is we covered all the big stuff, all the things you're going to hear in most Hadoop-related discussions. I also want to point out some honorable mentions here that I didn't have in the list, and then we'll head over to the Incubator site so you can see how to stay on the bleeding edge of Hadoop projects yourself. So Knox holds some promise in the world of centralized security for our Hadoop cluster. HDT, Hadoop Development Tools, a set of tools that are going to integrate with Eclipse to make developing things like MapReduce jobs a lot easier. Spark was just announced a week ago, and even just a few days ago accepted as an Incubator status project inside of Apache. And this is really cool. Spark does hold a lot of promise. It claims to be 100 times faster than core Hadoop. It sits on top of Hadoop and takes all the data on the disks and puts it into memory. So it takes the disk problem that we have right out of the equation, stores it all in memory, so all your queries, your Hive and your Pig queries are just hitting in-memory data all the time. They also have another one from the same people, same community, called Shark. It does the same thing for Hive that Spark does for Hadoop. Let me just briefly take you over to the Incubator website so you can see where to look and how to find things. Here we go, incubator.apache.org. Little detail on the main page here about what the Apache Incubator is all about. If you scroll down, here's a list of all the current Incubator projects. Now, you can get a much better view of this stuff if you just do a / projects. This will give us a one-screen shot at all the projects currently in incubation with their descriptions, when they were added in as incubation projects. You'll see a lot of things that look familiar in here. HCatalog, Hadoop Development Tools. There's Drill up there. If we scroll down even further, we'll see Spark, which was literally just added in not long ago. And if you scroll down even further, we can see projects that graduated from incubation. So here we'll find everything from Cassandra to Pig to Hive to Scoop. All the things that we looked at here inside of the core Hadoop stack will be in here in some form or another. And then even at the very bottom, you can see things that didn't quite make it out of incubation. So there we go. The last thing I wanted to show you was a visual on what a Hadoop implementation might look like. And here's a very basic generic one. But essentially we have core Hadoop here, Hdfs, MapReduce, so you get all the binary set up, you have Hadoop up and running. And this is also, by the way, a great way to learn. Set up a roadmap with all your technologies and start from the center and work your way out. Kind of like what we're going to do. We're going to do the same thing in this series here. So there's your core. Then we've got our technologies for working with the data the easy way, not at the MapReduce level, but the easy way through Pig and Hive. Then we've got just some data integration technologies set up here. Scoop, if we want to, say, integrate with a relational database. Flume, if we want to bring our logs in here into Hadoop. Ambari for managing and provisioning the entire cluster. Ambari is just an awesome project. Zookeeper for the coordination, HBase for the column store, and there you go. We should probably add HCatalog in here too for giving that consistent view across these technologies. But there you go. There's a very, very basic implementation of what it would look like. In this TBT Nugget, we learned about the Hadoop technology stack. We started off with the core of Hadoop. We saw that the core is really Hdfs and MapReduce, and in the future, Hadoop 2.0 Yarn is going to be a part of that. We talked about projects that spanned a wide array of categories, everything from data access to data storage to data intelligence and even data serialization. And then we talked about incubator projects. Took you over to the Incubator site. We saw how to see the current status of incubator projects. And at the end, we just took a brief view here of what an implementation might look like, so you can get a visual of how all this stuff works together. I hope this has been informative for you, and I'd like to thank you for viewing.